This video involves the usage of the law of cosines. When we have a right triangle, we can use our trigonometric functions, Pythagorean's theorem. We can get all the information we need about the triangle. But when we don't have a right triangle, we need some different laws to work with. And that's what we're going to work with today. We're going to look at the law of cosines, and we're also going to use the law of sines. The law of cosines has two forms. It has the standard form as well as an alternative form. What's the difference between them? The standard form, all right, it has basically your sides and an angle. Your alternative form has an angle, and then you use it to solve for with your sides. So let's go ahead. At this point, pause the video. Write these down so they're in your notes. Then you can use them on your quiz, but write these formulas down. And we'll come back, and then we will go ahead and we'll do an example. All right, let's go ahead and look at an example. Here we have a triangle. We're given three sides. We're told that b equals 3, a equals 7, and that c equals 8. I have no information about the angles. I only know about the sides. So let's go ahead and figure out then what we can do with this using our law of cosines. I'm going to go ahead and I'm going to use angle C. So that's going to be then the cosine of angle C equals a squared plus b squared minus c squared, all divided by 2ab. I chose to work with angle C. Did I have to? No. Could I have chosen angle A or B? Of course. At this point, let's go ahead and plug our information in. So let's see. A in the original triangle was 7, so when we square 7, we get 49. In the original triangle, B was 3. When we square it, we get 9. And in the original triangle, C was 8. And when we square it, that's going to become 64. On the bottom, we're going to have 2 times 7 times 3. When we put this into our calculator, what's going to come out is going to be negative 0.1429. Okay, remember, I want the angle C, but I have a number. So how do we move between the number and the angle? Well, we use the arc function. So inverse cosine or arc cosine of negative 0.1429. And if you put that into your calculator, we're then able to get an angle for C. So C is then equal 98.21. All right, let's head back up to our triangle. So we have information up here about C. We know that C is 98.21. I still don't know anything about angle A. Once I get one of these angles, A or B, I can then just use the fact that they have to add up to 180 to get the other angle. We could use the law of cosines again. Let's go ahead though and let's use the law of sines. So if we write then sine of B, the angle, over B the side, right? That's then going to equal sine, and I just found the angle for C over side C. All right, so we don't know what that angle is, but we know the length of that side. So it's going to be sine of B divided by 3. That's then going to equal sine, and I just found my angle C, which is 98.21 divided by the side C, which is 8. Okay, you cross multiply the 3 and put it into your calculator, and you come up then with the sine of b is then going to equal 0.3712. Remember, we want the angle b, so we put it in as an arc or an inverse function, and then b is going to come out to be 21.79. So what do I have here? We know this is 98.21, and we now know this one over here is then going to be 21.79. That leaves us one more angle to deal with, and that's angle A. Now, what do we know about a triangle? All the angles of a triangle have to add up to be 180. So getting the last angle, we only need to take 180 minus our 98.21 minus 21.79, and that's going to equal 60 degrees. So that is then our angle A. So angle A here is 60 degrees. Okay, we have now successfully solved the triangle. Let's go ahead and do another example, and let's look at what we're given here. Here we're given an angle 75 degrees in 20 minutes. We're given one side, which is 6.2, and we're given another side, which is 9.5. Notice I have side A and side C. In fact, we can go ahead and start labeling our triangle. If this here is angle A, then this is 6.2. All right, if this is C up here, then this here is 9.5. I don't know anything about this side. All right, but I do know that this angle here is going to be 75 degrees and 20 minutes. To start this problem, we're going to have to deal with the 20 minutes. So let's go ahead and convert that into a decimal place. All right, so if we have 20 minutes, if we take then 75 degrees, and then we're going to have 20 divided by 60, and when we do that, we're going to end up then with 75.33 degrees. Okay, now we can go ahead and we can start using this, but what are we missing? I have an angle and I've got two of the sides. I don't have any information here about this B side. We're going to use then the standard form of our equation, and so let's go ahead and write that down. I'm after B, so we're going to use B squared equals A squared plus C squared minus 2AC cosine of B. I have all the other information, right? So this is going to be 6.2 squared plus 9.5 squared. The 6.2 and the 9.5 was given to us in the problem, minus 2 times 6.2 times 9.5 times, then we're going to take the cosine of 75.33. All right, when we do this, if you would put all this into your calculator, we're going to end up with a B squared, which equals 98.86. When we take the square root of both sides, B is then just going to equal 9.94. I understand when you take the square root of both sides, you get a positive and a negative answer, but we can't have a negative side of a triangle, so we're going to just disregard that answer. So our b here, we just figured out, is then going to be 9.94. Now we can go ahead and we can use the law of sines to go ahead and get our other angle. So let's do that. Alright, so we'll go ahead and we'll find the sine of A over A. Now on this case, it doesn't matter which one we go after, if we go after A or C. This is then going to equal the sine of the angle B over the side B. Sine A I don't know, but the other numbers we can start putting in. So we're going to have sine of A over 6.2. That's then going to be sine of 75.33 divided by 9.94. Alright, when we do this, we end up then with sine of A is then going to be what? It's going to be 0.6034. We get that from cross multiplying that 6.2 over and putting it into our calculator. Once again, we go ahead and take the arc sine, and so we can get the angle A is then going to be 37.1 degrees. So angle A here is 37.1. That only leaves one angle, which is angle C, and we really don't need to do much work for that. Okay, because what do we know? We know angle C has to equal 180 minus my angle A minus my angle B. And so angle C is then going to be 67.57. So this angle here is then 67.57. Okay, and that's basically using the two different forms how we go about completely solving the triangle. One more thing I'd like to discuss, and that is, when do we use the law of sines or the law of cosines? So let's look at this first one here. I'm given a side B and a side C and an angle C. Since I have both the side and the angle here, I can then use the law of sines. This second one, I'm given A equals 4, C equals 5, B equals 52 degrees. Now, what do I not have? I do not have a side and an angle that match on this one. So because of that, I have to use the law of cosines. This one, I'm given 3 sides. I have no information about the angle. That's very similar to the first example we did. So on this one, you're going to use the law of cosines. Finally, this one here is a little tricky because I'm given angle A and B, and then I'm given side C. All right, but I only have information about one side. You can find angle C because they have to add up to 180, and once you've done that, then you're going to go ahead and you're going to do the law of sines. And this concludes the discussion of how you use the law of cosines.